Okay, here we go, guys. For you, it is Friday. Oops, need a pen. Friday, January 15th, and we are working in section 6.3, day 2. All right, here we go. The equation of the unit circle. All right, unit circle centered at 0, 0, radius 1. So that's x squared plus y squared equals the radius squared, which is 1. And we know that x on the unit circle is equal to cosine theta, and y on the unit circle is equal to sine theta. So we can come into here, this x squared, and we can replace out x with cosine theta. So we're looking at this, cosine theta squared, plus, same thing, replace out the y's, sine theta squared equals 1. Now, the parentheses get to be kind of cumbersome to write in here, so there's a notation that we can use, and it looks like this. Cosine squared theta, so we put the square on the cosine. It means cosine theta quantity squared, plus, likewise over here, we can put that square on the sine, and write sine squared theta. That means sine theta quantity squared is equal to 1. Important note, cosine of theta squared is not equal to cosine squared theta. On this one, the theta is squared, and on this one, the x coordinate on the unit circle is the one that's squared. So be very careful about that notation and what it means. This is a very, very important equation that I want you to memorize. It will become the most important trigonometric identity that there is. And an identity is a statement that's true for all values in the domain. So that's one of them. There's a variation on this. If we take each piece and divide by the same thing, specifically, let's divide by cosine squared. So I've divided everything by cosine squared, which is perfectly legal. And then this simplifies down to be 1 plus sine squared over cosine squared. That's tangent squared equals, and 1 over cosine squared, that's secant squared. That's important. That's a variation on this first one. And we could take that original and also, instead of dividing out by cosine squared, let's divide out by sine squared. We end up with then that's cotangent squared plus 1 equals cosecant squared theta. Very, very important. All right, these three collectively are called the Pythagorean identities. Pythagorean identities. They all stem from x squared plus y squared equals 1, all going back to that unit circle and that right triangle, a squared plus b squared equals c squared. Pythagorean identities. Please memorize these. Please memorize these. And one more time to make sure you got it. Please memorize these. All right, let's go ahead and see if we can use some of these to solve some problems. We're going to evaluate these without your calculator. All right, cosine squared of 25. Is that 25 degrees a nice spot on the unit circle that we've memorized? No, it's not, but we notice that this fits that pattern. Cosine squared of something plus sine squared of the same something, that's 1. That's 1 right there. All right, how about secant squared 18 minus tangent squared of 18? Well, we know secant squared is equal to tangent squared plus 1. Just wrote it in backwards. So secant squared minus tangent squared is 1. All right, this one, sine of 92 times the cosecant of 92. Well, cosecant's 1 over sine, so this says sine of 92 times 1 over the sine of 92. Oh, look at that. That's 1. All right, how about this one? Tangent of 200 times the cotangent of 20. Now this one's different because the other 3, we had the same angle every time. This one's different. All right, so what we kind of want to do is to get these to be exactly the same angle. So we need to think on the unit circle about where 20 degrees is and about where 200 degrees is. 20 degrees right there. 200 degrees right there. Oh, look at that. They're exactly halfway around the circle from each other. All right, well, look at this 20 degrees right here. Tangent of 20 times cotangent, tangent of 200. I want to look at this 20 degrees. Look at this 20 right here. We know cotangent repeats itself every pi radians, or every 180 degrees. So these two are exactly 180 degrees around from each other. So this 20 degrees has exactly the same cotangent value. Because 20 degrees and 200 are exactly halfway around, they have exactly the same cotangent value. Would not be that way for sine and cosine. It only works halfway around because cotangent repeats itself for halfway around. All right, now it might be helpful if you could write this as the sine of 200 divided by cosine 200 times cotangent cosine 200 times sine, divided by sine of 200. Oh, look at these. These all cancel out. And we are left with 1. Okay, right there, if you happen to remember that tangent and cotangent are reciprocals of each other, and anytime you multiply 2 reciprocals, you get 1, that's perfectly fine. You can get away with not writing that line. All right, well, so far it looks like every answer to all of these problems is a 1. Sadly, the last 2 aren't. They are not 1s. Let's see if we can figure this out. Let's do the secant of negative pi over 18 times the cosine of 17 pi over 18. All right, somehow I need to get these angles to be exactly the same. So what I need to do here is look, well, you know what? First I'm going to rewrite that as 1 over the cosine of negative pi over 18 times, this is the cosine of 17 pi over 18. Where's negative pi over 18? Negative pi over 18 is right down here. It's pi over 18 going down. 17 pi over 18 is all the way over here. Here's 17 pi over 18. And do you see that that 17 pi over 18 is pi over 18 up from this pi? So this amount right here is exactly the same as this amount right here. They're just going in opposite directions. Same amount. Now remember, cosine talks about the x coordinate. So look at this. The cosine, or the x coordinate at negative pi over 18 versus the x coordinate at 17 pi over 18. They're the same lengths, just opposite signs. So right here, we could say that this cosine of negative pi over 18, that is the opposite of the cosine of 17 pi over 18. All right, let me say that again. The cosine of negative pi over 18, so the x coordinate right here is the same magnitude but opposite sign, S-I-G-N, of the x coordinate at 17 pi over 18. These are opposite directions for x coordinates, same size. So the cosine at negative pi over 18, the x coordinate here is the opposite of the x coordinate here. So I replaced out that cosine of negative pi over 18 with the opposite of the cosine of 17 pi over 18. And then we see these cosine pieces cancel out, and we are left with a negative one. Oh boy. All right, let's take a look at this next one. The sine of 70 divided by the cosine of negative 430 plus the tangent of negative 70. 3 different angles this time. We need to kind of look at what's going on. First thing, let's get rid of this negative 430 because that's more than one time around the circle. So let's take a look at that. We have a positive 70, which is right there. We have the negative 70, which is right down here. And we have a negative 430. Well, negative 360 gets you all the way back to here. And then there's, oh my, 70 left over. So this negative 430 is the same position or same location as the negative 70. So this one right here, I can rewrite this as sine 70 divided by the cosine of negative 70 plus tangent negative 70. Sorry, it kind of got run over there. Can you read that? The negative 70. All right, so now I've taken 3 angles and I've gotten them down to 2. And I have the 2 of these negative 70s. So let's see if I can get rid of this positive 70 and turn it into a negative 70. And I'm looking at this sine value. All right, so let's look at the sine, or the y coordinate at 70 versus the negative 70, because I want to get it into negative 70s. Look at the y coordinate here versus the y coordinate there. The y coordinate at positive 70 is the opposite of the y coordinate at negative 70. Opposite of the y coordinate at positive 70 is the opposite of the y coordinate at negative 70. That means I can take this sine, which is the y coordinate, and say that that is the opposite of the y coordinate at negative 70. Oh, look at this. Sine of something divided by cosine of something. That's tangent. So we have the negative tangent of negative 70 degrees plus the tangent of negative 70 degrees. That's 0. that's 0. Tangent of something minus tangent of the same something, that's 0. These are tough when you have to change around the angles. They take practice. Draw the circles and visually look and think about the symmetry of the circle. All right. Couple more things going on here, kind of a few bits and pieces. That's why this squiggle is here, to kind of change thoughts for a few minutes. Do you remember even and odd functions? An even function is a function where the graph is symmetric. About the y-axis. And an odd function is where the graph is symmetric about the origin. Uh-oh. We don't have these graphs yet. They're coming. They're coming very soon, actually. So, we have to go back to the formal definition of even and odd. An even function says that f of opposite x is exactly the same thing as f of x. An odd function says f of opposite x is the same thing as opposite f of x. So let's think unit circle here. Here's x. Where's opposite x? Opposite x is right down here. All right, which trig functions have the same values? So when you find a value at x, it's the same thing as opposite x. It's cosine, because the cosine of opposite theta is the same thing as cosine theta. So cosine is an even function, as is secant. The secant of opposite theta is the same thing as secant theta, because the x-coordinate at this point is exactly the same thing as the x-coordinate at that point. The other four are odd. Sine, cosecant, tangent, and cotangent are all odd. Sine, the y coordinates are the same size, but opposite signs, opposite directions. Same thing with cosecant, tangent, and cotangent. So secant and cosecant are even, sine, cosecant, tangent, and cotangent are odd. All right, one more example. F of theta is cosine theta. So that's telling you that's the function. And f of a is 1/4. If the function is cosine, then this means the cosine of theta is 1/4. Cosine theta is 1/4. The x-coordinate on the unit circle is 1/4. So maybe right there. There's a. Oops, cosine of a, not theta here. Cosine a is 1/4. What's f cosine of negative a? There's a, that's at 1/4. The x-coordinate's 1/4. What's the cosine of negative a? Right down here. Yeah, that's also 1/4. Same x-coordinate. All right, let's look at this one. Now again, your function is cosine. So this is saying the cosine of a plus the cosine of a plus 2 pi plus the cosine of a minus 2 pi. Cosine A is 1/4 plus, sorry about that, my mom's texting me, cosine of A plus 2 pi. Well, here's A. Where's A plus 2 pi? Same spot, so it has the same cosine value, 1/4, plus this one, A minus 2 pi, same spot, so same cosine value, and that's 3/4. Whew. All right. Thank you very much for your attention the past couple of days, listening to the videos, and we'll try and clean up things on Monday. No, Monday. There's no school Monday, so we'll try and clean up things on Tuesday. Thanks, guys. Have a nice weekend. Bye.